Control volumes are widely used in hydrostatics and fluid mechanics for deriving equations describing the state of a fluid. So, what is a control volume? A control volume is a region in space bounded by a control surface. The size and shape of a control volume is entirely arbitrary, and it depends what we're trying to do, which shape we use. It could be spherical, cylindrical, cuboid, or any other three-dimensional shape. Here, a control volume with rectangular sides is shown, which is convenient, for example, when we're using Cartesian x, y, and z axes. Frequently, we make control surfaces coincide with solid boundaries, or, in cases involving flow, assume them to be normal to the flow direction to simplify derivation of equations. So, for example, if we're dealing with flow in a pipe, the obvious thing to do is to take two cross-sections perpendicular to the flow, and we let these cross-sections and the pipe walls define the control surface. The control volume is then contained within that control surface. We often represent this more simply using a 2D projection, such as that shown here. Similarly, for a channel, we can use two cross-sections, the channel sides and bottom, and the free surface of the water between the cross-sections to define a control volume. You will see throughout my videos on hydrostatics, fluid mechanics, and computational hydraulics that this simple concept is an essential building block in deriving equations to describe the behavior of fluids. I hope you enjoy watching. Bye for now.